There we go.
And then do I have
You're
a
on.
click?
You're already on.
But click is just this one?
This one right here. The left and right.
Okay, thank you. All right, hi everyone, sorry for that. Again, Gigi Carmis Edwards, and today I'm going to be representing the Swan organization, Smart Water Network organization. It's been around for about 10 years, and I approached them about a year ago about creating a new working group on digital twin technology, and they've agreed to it. We ended up having 2 workshops already. We're collaborating on many things globally so that we can make digital twin technology a part of everyday and within utilities around the world. So that's really the focus of the digital twin working group. But I'm going to talk about why we need a Smart One Water ERC today, why today is so specific. What is digital twin? I'll go through that. I think, again, the concepts are very similar to what Dr. Sunil's been talking about, and how digital twin can fulfill the promise of a Smart One Water. So today, utilities around the world are deploying an array of disruptive technologies, and we're seeing more and more of these technologies every single day. We're seeing a lot more sensors. Sensors are becoming cheaper, but they're also developing new sensors to detect new things that we need in the water sector. Cloud computing and mobility is completely a game changer. It has changed everything because instead of relying on premise servers to run some of these machine learning, artificial intelligence type of software that uses a lot of resources, we now have the elasticity and the elasticity of cloud computing, and also it's much cheaper, so people can then run more advanced applications. Of course, there's new business models now. X as a service, anything as a service has changed a lot of things for utilities. We've also always have used the hydraulic model for engineering and expansion purposes. But now with cloud computing, with the ability to run real-time simulation, and feed it real-time data from the real systems, from the physical systems. And I'll talk a little bit more about that in a minute. Drone technology, utilities are deploying them as well. Customer engagement has completely changed over the last few years. Customers are expecting more. We live in a digital world. They should be able to interact with their water utility. They should understand the quality of water at all times, how much water they've used at all times. So we have to really change the way utilities engage with their customers. And then artificial intelligence and machine learning, as you know, is completely on the increase. Everyone knows that now we can use all these software algorithms to get insights from all the data that we are collecting. Virtual reality and augmented reality is here today. Everyone is already starting to use it. This should be a commonplace for all of our water facilities. 5G is on the way, blockchain technology, all these disruptive technologies are really going to change the way we interact with the society in terms of water. Now, all of these things are deployed today, mostly in siloed concepts. They're point solutions. They're trying to solve a single solution, whether it's leak detection, energy efficiency, improve customer engagement. But really the power of all of these disruptive technologies is the interconnectivity of these technologies and connecting the dots. And I think that's really what this Smart One Water center will focus on. And there's a need for that. And today, this is where we sit. We have all of these disruptive technologies. They exist, but we haven't connected all the dots. And a center like this could really be a game changer for us. And I also see that as creating the digital twin. So now I'll talk a little bit about what a digital twin is. Digital twin is basically a software or digital representation of a physical system. It represents not only the static elements of that system, but the behavior of that system, the dynamicity of that system. And in order to do that, there has to be a continuous integration of real-time data from the physical system into the software model. And digital twin technology could actually be used in the design phase, in the construction phase, as well as the operational phase. So far in the Smart Water Network, in the Swan Digital Twin Working Group, we focus mostly on the operation side because we have most of these utilities built out, but really to take full advantage from now on, as we start to build out, we deploy digital twin concepts in order to optimize the design before even digging the first hole. And that's what I mean by using a digital twin in the design phase and as we go through construction. So in a little bit more details, let's say you have a water utility that has a SCADA system, a CMMS system, lab data, sensor data. We have the GIS system. We're bringing in weather data. All of these, in most cases, one of the biggest challenges that utilities are facing today, as I understand it, is most of these data sets are siloed. They're sitting alone. It's very difficult to integrate all of these data sets. That is the promise of digital twin, is once you can start to integrate all of these separate, disparate data sets, and you use a model to represent the behavior of your physical system, you now have the concept of a digital twin. The benefits are enormous. This digital twin can start to have insights into the future. You can run simulations and do predictive analysis. It actually acts as, once you calibrate a digital twin, once your digital software twin is calibrated with real-time data, it actually acts as virtual sensors everywhere. You can start to understand what is the pressure at any point. You don't have to have a pressure sensor there. It becomes a virtual sensor anywhere. It actually causes departments across utilities to start to work together because this is a collaborative type of tool. Everyone from the business side to the field workers to the operations, all of the departments will interwork with one another through the use of a digital twin. You can do what-if scenarios. You can find out if there's a leak somewhere because you're now detecting anomalies at a minute scale. You're not waiting for a catastrophe to happen. If a pressure change that seems, it doesn't seem right, you can say, oh, well, let's try to investigate and find out why this pressure change happened. And maybe you can get to a root cause of a problem that would exist in the future, but you catch it very early. So it's very cost effective. So there's many different benefits, and we can go on this. But the essence of digital twin, which is the essence of what we're trying to do with the Smart One Water Center, is it's really about having physical systems, having a virtual system, and the data interconnections. Those are the three key elements, and those are the three key elements that we see this engineering center really focusing on. And with that, you have historical data, you have real-time operational capability, you also have a tool to provide you with predictive analysis and what-if scenarios. And the real promise, and this is what the center is really about, if you can develop a digital twin for our drinking water utility, another digital twin for our wastewater, another one for stormwater, and yet another one representing our source water, whether it's groundwater, surface water, desalination, all of those digital twin concatenating with one another actually inform each other and allows us to be even more efficient within each of these spaces. So I always look at it as 4 different areas: drinking water, wastewater, stormwater, and source water, which is very consistent with what this Smart One Water Center will focus on. And we believe that this is the promise of SOW. Now, as I mentioned, I approached Swan to create a digital twin working group. And so now we're up and around. We've been around for about, I would say, 9 months now, doing very well, accomplishing quite a lot. We're developing a software architecture, a global software architecture to represent what digital twin means in the water sector. We will be working closely with the center in order to maximize the benefits of what Swan, an organization like Swan, is working on. So in conclusion, digital technology adoption is increasing, but like I said, mainly it's as point solutions, not integrated solutions. There's rich, useful data sets that exist everywhere, whether government is collecting data, whether the the National Weather Service is collecting data, whether different utilities are collecting all different types of data. Rich data sets exist, but what doesn't exist is the integration of all of these. So we believe that the Smart One Water Engineering Research Center will be the missing link to provide transformative vision of our water systems and to help develop a holistic view of one water digital system. And that will also inform policy. It will, and the future of how society really interacts with water in general. And that is it. So thank you.
Any questions, comments? Any question, comment?
Yes, there's a question.
Yes. Do you see any other infrastructures or other areas that have used this effectively, kind of as a model, or so that you could see its successes and some of its drawbacks of trying to put all this data together from disparate areas?
Yes, absolutely. I mean, we see it very common in the oil and gas field. We see it very common in airlines. You think about the flight simulator, that is really a digital twin. Manufacturing has completely, gone towards digital twin technology for optimization in manufacturing. Product development, in all other areas, actually. I mean, water, I think we're a little bit behind some of the other. Even in energy, they're a little bit ahead of us in terms of digital twin technology. Yes.
Have you thought about a fifth one, maybe climate impact, on how to more predictive technology?
Yeah, I mean, I think climate plays a big role in this, and it plays a big role in the stormwater, and the stormwater informs, the source water, which then informs, so everything informs the other. And yeah, climate has a big aspect to this, as also agriculture. 70% of the water produced is really going to agriculture, so that, a digital twin of farms and agriculture and the use of water, and concatenate that with water systems, really will lead to a more efficient use of water. Yes.
Are there any standards or frameworks you're using that are in place, or are you planning to build towards it with NIST or somebody else?
Well, not complete standards in water, but one of the things that we've introduced in the working group at Swan recently, so that you can start thinking of, the design phase, the construction, is BIM, Building Information Modeling. And so a few water utilities have started using that in their design phase. And what's odd, and I'd like to hear from utilities about this, it seems that you might have a lot of data. So in BIM, in Building Information Modeling, is really a mechanism. You collect a lot of data on all the assets. And then you also include the maintenance information, all kinds of information. But then somehow, going through the construction into operation, that's no longer being used as part of operations. And that's where I think we should see a continuum of data, especially any kind of data that could inform what we're trying to do.
Gigi, maybe two questions. First, have you thought about looking beyond just the water system itself to some of the other things that water systems are dependent on, such as, transportation for getting chemicals for water treatment or power, those sorts of things, as part of the digital twin?
Yeah, I'm also working on a project on a green city that's looking at all of urban planning. And actually, when we talked about optimization, using a digital twin in the design phase to optimize, let's say you're designing a drinking water distribution, then while you're optimizing that, because of the interactions of energy, you might have a digital twin of energy as well as water and combine them together to optimize across those two systems interacting, as well as, like you said, transportation or mobility and agriculture, all of these. So that's the full promise. But what I'm seeing is right now we are behind in water. Even when we talk about smart cities, you see energy as very prominent, you see transportation as very prominent, and we need to make sure that water becomes a very prominent player in smart city, which is, what you're trying to.
Right. Yeah, I'm kind of thinking of it from more of a resilience perspective, and so what does it take to actually keep that system operating? And it's dependent on things that are outside the scope of the water system itself.
Yeah.
My other question is, it looks like you focused a lot on the data sets that are available. Have you spent some time thinking about the questions that you're really trying to answer by being able to integrate those data sets?
You mean data sets that don't exist today that we're not already collecting?
Or what are the problems that you're trying to solve through integration of the data sets?
Yeah. I mean, I haven't spent a lot of time on that, but I think that will come out of it. That will get distilled through a lot of this effort. And especially as sensors are now, being developed that are collecting data on things we never thought we would collect data on. So I think that is a very important point. Yes.
So I like the, technology perspective on that you're describing. I think it's got a lot of promise. I do think we need to think about, take a systems perspective of water and all its associated things. I guess my question is, to what extent are you really focusing on certain areas? I mean, it's nice to say we want to be everything, but at the end of the day, there's maybe different types of situations. I think the situation, for example, water for a city is quite different than the issue of water for Nebraska or water for the Klamath Basin or water in the Hampton Roads area.
Yep.
Right?
Yep.
Those areas. And so I guess are you trying to provide, something for everything, everywhere, anytime? Or, are you focusing deliberately on certain aspects?
No, because, like I said, there's 4 entities in water that we focus on, and eventually that should cover, ideally in a cartoon world, I would be able to follow a molecule of water all the way from the time it fell out of the sky into the source, into the treatment, into the water distribution, into the sewage system, out the sewage system, migrating with more storm water and back into the source. That should cover all of the scenarios that you talked about. So this is really focused more on data-driven knowledge, data-driven decisions, and ultimately, which I think we're not there yet, ultimately, automation. And in order to get to automation, we really have to feel comfortable with software algorithms giving us insights. And once we feel confident that that's consistent, we can then start to go towards automation. But it should cover all of those scenarios.
Yeah, I would argue that we do have, you talk about rich data sets, and it's true that we have some pretty rich data sets. Generally speaking, those rich data sets are where there are people rather than where there are no people. Mm-hmm. And so, thinking, I think, echo the last comment, thinking about, where we have information gaps that may be critical, I think is really important.
All right. Well, we'll put that as one of the areas that we can focus on in this, the working group. So thank you both.
Okay.
Oh.
So I have one quick question. Have you considered tapping into organizations like OpenAI or Kaggle to help your artificial intelligence machine learning element? Because once we have this rich information and data, then how do you innovate in an innovative way tap into these communities that I think from creating this partner ecosystem that's going to be necessary.
Yes.
I think that's an important part. Have you tapped into any of those organizations?
No, but I'd like to learn more if we can talk afterwards.
Yeah, we're doing some AI things, and those organizations have been incredibly helpful. So
I think that would be fantastic. Yeah. Thank you.
Okay, so let's move on to the another. We will
We'll
have
talk
more
later.
discussion. The whole presentation was mainly to get us people thinking about it and the discussion topic we have not. So water, from what we'll talk about intelligence, then we will go to the